Hello everybody, this is Schwab again. This time I'd like to show you a very important part of the post-processing. This is a part of the 2D FEM and 3D FEM. And as you know, the post-processing of general equation solver programs can be done by many different ways, like cuts, isosurfaces, and so on. But one of the most important ones is the path lines or streamlines. So let me show you first a project which is already solved. This is a kind of co-extrusion channels, just for you to understand how does it look like. I'll show you the revolved view. This is simply a co-extrusion of two materials, each is coming in as a ring of polymer and merging here. Well, this is the flow domain, and we can make here arbitrary path lines. So I just can go to grades created path line here, or even in operations I have that command. And basically, if I move here over that domain, it automatically creates a path line and previews the current variable. If I click, that point is taken as a seed for that path line, and we can visualize different variables along. Basically, we have all the variables which we see for other grids, plus we have few more extra. For example, along the path line, I can look on the time, or I can look on the strain. So there are few more which don't have any meaning for let's say the 2D or 3D grids or meshes, but they have the meaning for a path line. Like time, of course, is a variable which is having meaning on a path line only. Now we also can have any variable as a function of length or as a function of time, which is slightly different curve. I should also say that if you just try to edit that path line, you can only start that command again, and it will do it. We know that the right click in the graphic area repeats the last command, and that was the last command was editing. So if I right click, I'm again in editing of the seed, and I can put it anywhere I like. If we have the focus on the parent grid, and if I right click, he will understand that I'm not going to edit that path line, but I'm going to make another one, right? So this way I can make multiple path lines and see one or the other one. I can delete now one of them. Now we also can see that basically the seed is having a length and time 0. You see, this is the length from that. So if I'm before, my length is going to be negative. If I'm after, my length is going to be positive. The same is for time. If I just go to here, I have negative time. I'll go here, I have positive time. So this particular path line goes from minus 0.12 up to 0.1 or something. So it's very short time, 0.22 to get out. Well, we can also see that when I'm moving along the path line, I see here first the green and the red points. The green is the seed. Here in the APP dialog settings, we have some settings for the path line. First of all, the seed. I can say I don't want to see the seed. And now simply if I'm moving there's no seed, right? Or I can say what is the color of that seed point, right? Also, if I'm moving in the graph, I see the red point. I can say show that always. Now, it's visible normally only when I'm in the graph in this dialog. But if I check always, it will be visible always. You see, it's visible. Now it's not visible anymore. So that is again very useful thing. I can also set up the appearance of that seed or the appearance of that graph point, right? We also can change whether the graph is in units or pixels. Normally it's in pixels. What it means, I can demonstrate probably on the seed. You see the seed is in pixels now. So when I zoom, it remains constant size. It doesn't zoom with because this is always certain pixel size. But if you change it to units, now it will be this number here is the 0.5 millimeters. So it's scaling up and down because it is really in millimeters, it's not in pixels, right? So let's put it back to pixels. Normally we want it in pixels, but there are some cases where we want them in units. For the graph, we have one more option. We have a markers ratio. What it is, if I say markers ratio, I will get a slightly different ball. That ball is in fact a marker, right? For pressure, this is a scalar variable, so I see only a ball. But if I go to a velocity vector, well, this is not a velocity vector. Honestly, this is a scalar. It's a velocity magnitude, which is linked to a vector. So we're really previewing the velocity magnitude, the scalar variable, but we know that this is linked to an extra variable called a velocity vector because it is coming from that velocity vector. And now you see, you start to understand the flow of those particles, and you see also the arrow. Well, these markers, first of all, I'm using 1.5 times the size of the marker, which you can change here. And the markers are defined over here. So we can see the scalar board, we can see the vectors. I can change the size of that arrow. I can change the shape of that arrow. Simply, I have lots of flexibilities. Also, you may see that the vector is constant size. I can scale it by value. And now that vector will be large here, but in this area it's very small. Well, that's very dangerous. Why? Because if I just put a seed somewhere here, close where we have small velocity, of course, now you have difficulty to even see this small arrow, right? Because it is scaled to 0 or almost 0 in those regions. So I usually, for vectors, I just don't scale by value, right? Keep it constant size. We also can have a variable which is linked to a tensor. That would be a stress magnitude, right? The stress magnitude is calculated from a tensor of stresses. So when you choose that and you have here in the OpenGL the markers ratio, you can just see the shearing and elongation. If I just go somewhere here, I'll see more elongation, right? You see the stretching here and compression. And if I would be close to the wall, let's say here, I would probably see some kind of shearing. Now, when we're in 2D FEM, I should also explain how the streamline is calculated. It is calculated from a stream function. If I put to the main grid a variable called Streamfunction, you will see that this particular variable has a red on one side, number 1 is on the left side, and the 0 or blue is on the other side. So this has been found during the solution, and this basically says for that particular mesh and for that particular interface, it shows how the polymer is flowing through. So basically, the ISO contours of this variable are giving us the flow passages of the polymer. In other words, you may say that always this size represents the same amount of mass. You see, yellow color now represents a certain amount of mass. The orange represents a certain amount of mass, and so on. Now you have to imagine that this is, of course, a ring of that polymer, right? So they have different diameter, those rings, etc. And basically the streamline is nothing else than isocontour of that stream function. That's why it is also using this small dialog, which you probably are used to see when you're doing isosurface or isocontour. Okay. Now we also can do something more with those streamlines. We can say animate markers. Well, this animate marker is a very nice feature. First of all, this dialog is modal, so you cannot click anywhere unless you close this. So you cannot rotate or pan, right? Most of the dialogs we have modeless, but this one is modal. And first of all, you set up, I want one marker, and then if you do single shot, you will see that marker. Well, it went through very fast. You have to slow it down a bit, right? And now single shot, and you see it coming through. I want to do more of them. So if I just say 5, I can say animate, and now I see 5 of them, and once they're gone, they reappear at the entrance. Now again, during the animation, I can just slow them down, And also, there is a small delay between advance, so you can just make that delay very small to make it look more smoothly. Here I'd like to warn you about one important thing. If you just put here more steps and you start animate, you see for very slow movement this looks very natural. But what if I start to move faster? It start at a certain time it starts to look like that they're going back, right? Well, they're not going back in fact. They're going always forward, but this is a stroboscopic effect, which is causing an optical illusion. So we just have to slow down that animation. Well, there is a lot of potential, but let me just make more path lines to see that. Well, to be able to do that, we can always animate only one markers on one streamline, but that streamline can be not real, and we can have a multiple. You see, I can have here three. Of course, the graph is gone because first I cannot see three at the same time, but I can say, let's say I want to have three of them, and now I can animate markers. So if I just say animate, it will show me, maybe 17 is too many, let me put there 5. If I say animate, I have on every streamline, I have 5 markers, and I'm seeing how they're coming through. Well, I can also stop that and say distance volume based. What is the difference? Now the difference is that he will take the slowest one and he will calculate 5 markers. Well, the fastest one will have then more. So if I just say animate, maybe it's not even obvious. You know why? Because we need to, they are more or less having the same time. But here I show you one more option. We can edit the positions. Now these streamlines were equidistant, 0.25, 0.5, 0.7, but I can make them, I can reedit this with 0.95. This one can be, let's say, 0.05. If I say accept, you see I have one streamline here, one is in 0.5 and the other one is, so these values here were the stream function values, right? And if I just say animate markers, now I will have 1, 2, 3, 4, 5 here, but 2, 4, 6, 8, 9, or 10 on the middle one, because the middle one simply represents more mass, so represents more volume. That's what this distance volume based is doing. If we uncheck this and we animate, we have 5 on each streamline. But if we check the distance volume based, then we have, of course, for those streamlines which represent more mass, more volume, we have a denser markers. So if I just change the numbers and I say do it again, I see the density here. So this density represents the amount of mass. Well, at the same time, of course, the amount of mass is represented by the speed of movement, right? So you see that these ones are moving much faster than here, because simply that there is a higher speed. Okay. Sometimes the users they don't remember how to switch on and off these markers. They don't remember to go to APP and change it here. So for those, I've here enabled these graph markers on off, so you can just check it now. Now it is off. And if I just do it again, graph markers on, I have the velocity vector. So if you don't remember where it is in the settings, you can simply go here and say graph markers on off, and that's it. Okay. With the streamlines, you can do basically all the transformations which you could do with the main grid. So for example, if you can revolve this main grid, of course you can revolve the streamline grid, right? And you can change the angle, let's say like this. Well, it doesn't have too much meaning, but you can do that. Also, you can do other stuff like a relief and all these things which are normal for any grid. So simply it's a grid like any other. Okay. You can also change its appearance and so on. Now sometimes it also happens that we have multiple path lines. So I have like one, and now I don't remember which one is what. Now, well, then I recommend to mark this one as red and this one, for example, as green. And now we can go to DOs and we will see that the curves are in fact, they are black, but when we have a grid color, they won't be black. They will respect that grid color. So let's just give them the grid color. This one we wanted just to make it red, and this one we just wanted to make it green. So you see, the only thing you need to do is just to say here what color you like to use. Maybe I can use yellow or a different gradient, and then I have simply the path lines distinguished by the different color, and that is making me easier for me to do some pictures, some animations, etc. And I see what this line represents. I should also say that sometimes the streamline is calculated. You can at any time recalculate that path line, right? You can just click recalculate and it will be done very fast because it's a 2D mesh. You also may convert it to basic 3D grid. See, now we have the grid here, and then it's like any other grid. You can export it, you can export the nodes. That we have the ability to export also here. You can just export, save as an ASCII file, these coordinates, and it will be saved as a text file, and then you can send those streamline values to an Excel.